to the Burn Boss Refresher. We have special guests, Wildfire Management, RDNA. We have Kim Ernstrom and team to discuss IFTDSS and how we can use IFTDSS to better improve our prescribed fire burn plans. Kim, take it away.
Okay, so let me give you just a quick little background on this. So what I'm doing with this presentation is we're using obviously the new tools that we have at our disposal these days, IFTDSS being the primary one. The real emphasis for me is using spatial tools, whatever they're called. Right now, we have IFTDSS, we have things like WIFTDSS, we have things like FlamMap. So those are all spatial, oriented tools where we have maps and stuff. Who knows what they'll be called in the future? But the point is using these spatial type of things to help us inform our burn plans. And this year happens to be the 25th anniversary of the Cerro Grande fire, which happened down in New Mexico back in 2000. So I work for the National Park Service. The rest of our team is Forest Service. But back in 2000, the Cerro Grande fire was a very significant event, obviously, in the life of fire management with the National Park Service. And it impacted, obviously, just like most of our big, notable escape events, they impact everybody across the country. And that's no different back then than it is today. So what we wanted to do is kind of do a little look back in time. And Brian, I'm glad you talked about the Lessons Learned Center and the prescribed fire reviews that are available in there, because I find tons and tons of value in looking back at these escapes and seeing how we can learn from them, because I think there's some very explicit things that come out of these reviews that are repeated over and over again. And I'm going to talk about that with this presentation. So that's sort of the gist of this. And let me go ahead and just roll through it. And if we have I'm hoping we might have a little time to demo a thing or two, but let's just see how we do on time. In fact, let me set my clock so I kind of keep things within our time zone here. Okay. All right. So I'm Kim Ernstrom. I work for the RDNA. I've been with the RDNA group for about 15 years since the whole thing started. And I worked down in the southern region for about 10 years before I moved to Boise, where I live now, and did a lot of prescribed fire with the Park Service, Fish and Wildlife. I worked at the Prescribed Fire Training Center down there, and then moved, out west here to Boise, and have been working on these applications and tools and things, and doing tons and tons of training on how to get people to use these tools. We've incorporated IFTDSS into the new RX 300 class. So it's now part of that curriculum, and we're working it into the RX or the S390 class as well. It's a much smaller part in there, but an introduction to using these spatial tools in S390. And then we've also participated quite a bit in the Fuels Academy and just a whole bunch of other Prescribed Fire Training Center workshops and such. So we're trying to, I think the word's out. We've got almost, 6,500 users now. IFTDSS is open to everybody, federal and non-federal. So anybody can use it. You can share it with your partners. Obviously, we have a very small staff, and our development, just like everything these days, our development budget is sort of in question at the moment, as we can imagine. So anyway, we're trying to keep the wheels on and keep things going. So hopefully in time, you all will be able to continue to use IFTDSS for some of these things. Okay, so what I want to talk about, there's 4 parts to this. I want to briefly go over some of these escapes and how they sort of fit into this 25-year history. Then I want to talk just for a second about technology and how it's changed. I'm going to walk through the Cerro Grande escape in a very, very brief sort of Cliff Notes version, and then we'll talk about how all these spatial tools roll into this whole discussion. So back in 2000, like I said, that was one of the biggest notable things that had happened in quite some time as far as prescribed fire goes. So we had that investigation, and as we move through time, the Lessons Learned Center back in 2005 and then again in 2012 did a sort of an overview of all prescribed fire escapes that they had access to anyway, and did a few summary documents, if you will. And then, of course, in 2022, we had the Las Despensas leading to Hermit's Peak and Calf Canyon, and had the national review. So over our little 25-year history here, we were able to pull out like recurring themes. So what I did is I put these sort of into color coding, and you can see like in the red, as we go across time here, things related to your prescription and fire behavior calculations. That was a theme throughout, this whole segment of time, and found in each of these sort of summary reports. The yellow talks a lot about fuels conditions, both inside of your burn unit and outside of your burn unit. And you can see that across time as well. The green, looking at fuel models and whether you're selecting fuel models that are representative of what you actually have on the ground. The pink is more about drought conditions, or quote, normal or abnormal fuels or weather conditions. Obviously, things have changed, as you guys well know, things have changed through time. We get a lot of, wow, I didn't think it was going to do that, type of fire behavior. And that's been a theme even back in 2000 and stretching all the way up until a couple years ago. Fire behavior was not what you had expected it to be. Another thread through a lot of these reports. And then the ones in blue have to do with contingency resources, which how do I determine what I need? Were they available? Those types of things. So these are sort of the main things we continue to see. And in fact, at the Prescribed Fire Burn Boss or Burn Plan workshop that they just held, I was talking to someone who just did a review in Region 4 in Utah. I think it was just last fall. And they said these same themes were coming up, even in the review that they did on that escape, just like in November. So that's why I think it's really important for us to focus on these things as we're writing our plans and seeing if we have tools at our disposal now to help address them. So that's where we're going here with this discussion. So technology, we have to think back, and looking back, 25 years ago, things have obviously changed considerably. Back then in 2000, we had Behave. Behave came out in 1984. We had our good old 13 fuel models. We were not using the 40 fuel models back in 2000. We had, we were using nomograms and the sort of the DOS version of Behave. Farsight had just come out in 1998. So that was brand new. That was the first sort of fire spread model that was available to everybody to try to learn how to use. And mostly it was folks up at the fire lab that were actually using Farsight at the time, because most people hadn't learned how to use it yet. So we didn't have, those fancier models that we have today. So you can see we didn't have the 40 fuel models on the right. Behave Plus, that version hadn't come out yet. That didn't come out until 2002. And we didn't have Landfire, which is another really important piece of this. Landfire didn't come out until 2001. So when they wrote the Cerro Grande plan back then, they did not have any of those things on hand. It was stuff on the left, mostly Behave and the 13 fuel models. So you got to keep that in mind when we talk about this escape. And again, we're not doing this to pick on anybody. It's more just to look at, what had we been able to write that plan today with the tools we have now, what might it look like? How might it be different? And how should we be going forward now that we do have these things? So technology now, as we know, we've got way too many things almost, right? We've got so many things we don't even know what to use. So, of course, I'm going to focus on IFTDSS because it's the one that's most related to fuels planning. But we've got all kinds of other things that are, on hand, and figuring out which ones to use and what's going to help us is kind of a, you kind of have to try, trial and error type of thing. Some are fairly common, but there's going to be a lot of other things that are continually being, developed. And I think the key here is really just finding something that works for you, and getting into a rhythm and a way that you want to do business. And then as new things come along, none of us have time to learn a lot of these things. So I think it's really finding one or two things that really work and get really good at those couple of things. Okay, so let's talk about Cerro Grande and how this all came together. So this was back in May of 2000. And just to get everybody oriented, we are northwest of Santa Fe, New Mexico, near the city of Los Alamos. And the Los Alamos National Lab is just to the south. So this is Google Earth. And again, another thing we didn't have back in 2000, but we do now. So that's where we're at with this slide. The green line is the boundary of Bandelier National Monument. So that's the park boundary. This burn unit was called Upper Frijoles, and you can see it's at the very head of this Frijoles Canyon, up at the top of the mountain here. This image actually is from 2006. So, in Google Earth, you can go back in time, and it's a really important thing to do with this particular story, because this area has probably burned over completely at least 2 other times. And there was the Las Conchas fire that burned this whole area over, and a few other smaller fires. So you have to go back in time so you can look at the vegetation and kind of get a better feel for what the folks on the ground were dealing with then, because it looks very different now. So this is a 1,000-acre burn unit. And the idea was, it was mostly ecological. You can see the objectives up here in the right-hand corner, was to, reduce encroaching conifer and, pole-sized classes, enhance aspen habitat. A lot of the aspen is sort of in the middle of the canyon at the head here, kind of a wetter environment. And you can see the open kind of meadows at the top of the mountain. So that's kind of what they were trying to do, is keep those open, keep the conifers in check. So the thought was that they could burn a kind of black line operation, the top, the north and west sides, and then work down the flanks of each of these kind of phases, if you want to call it. There's 4 phases in here. So the top is phase 1, and then the flanks would be phase 2, and then the middle is phase 3. So the idea was to black line phases 1 and 2, and then come back and burn out the middle. And, looking here, now that we have the luxury of using Google Earth, we can actually start to get a feel for what's in the neighborhood. And you can see Los Alamos is about 4 miles to the northeast, the lab, and then there's a ski resort about a mile, just over a mile to the north. The stuff on the west side is, at the time, was a private property called the Baca Ranch, which eventually got turned over to the Park Service. And so there was a little different deal over there, because they had private land, which is not the case today. It's actually public federally owned land now. Okay, so hopefully that sets the stage of where things are at on the landscape. Okay, so this is going to be the quick Cliff Notes version of the escape. So on May 4th at 7 o'clock in the evening, they started their operation. And this was the people that were assigned. They had 20 folks. And back then, that was pretty normal. That's how we did business back then. So the phase 1 was going to start blacklining from the top, down around to the west, and then down the flanks, right? Like we talked about. So that was the start. So that was at 1900, so 7 o'clock. By 2 a.m., one of the crews that they had to release. They had a 20-person crew, and the fatigue and hiking up and down this 1,000-acre unit. They decided they needed to let that crew get down the hill and get some rest. So they were short resources early in the morning. The burn boss and some of the other staff were still on the fire. So at that point, the burn boss decided he wanted to call dispatch and go ahead and get some of his additional resources rolling, so they had them in the morning. So he did that. He went and called dispatch, and they were told at the time that they couldn't have those resources, or they weren't sure because it was a prescribed fire and it wasn't a wildfire, so they should call back in the morning. So they were on the fire at 2 a.m., not knowing if they were going to get more resources in the morning or not. So that the rest of the crews that were up there kept trying to, hold what they had. they were starting to have some control issues, even that early in the morning. And there was very tall grass, and it was sort of spotting into the grass a little bit. So they were trying to recognize early that they were going to need some more help. Let's see. So then at 1 o'clock, then, so almost 12 hours since they started the original test fire, at 1 o'clock in the afternoon on the next, that day, they again continued to have these control issues. You can see in this, I know it's small, but on the east flank here, they had a slop over and some spots. And they went ahead and called in an air tanker to get some of those spots dealt with. And they decided to declare it a wildfire, mostly because that was the best way to get resources. Their contingency resources, for whatever reason, the communication to get those contingency resources was not working. So they decided to declare it a wildfire. At that point in time, they, or just before this, they switched leadership. And this is when Paul Gleason was still working for the Park Service and took control of the fire from the burn boss and assumed role as the Type 3 IC. So Paul took over the operations here and was running this now as a Type 3 operation. But the intent was still to kind of still do the burn as they intended. And they weren't worried about the thing really going crazy at this point, but they wanted to have those resources so they could kind of get done with it. So they went ahead and kept moving along with their operation. We go to May 6th, which is the next day, and they were continuing their suppression actions, just like I was talking about, down the east and the west flanks, which are the red lines here. And they were burning out along those flanks and using the resources. They now had an extra hotshot crew. They had a helicopter. So they had the resources they thought they needed to kind of get this thing buttoned up. And then they were going to come along the road here on the south end to tie off the south part of it. So, that was what their plan was. So they continued that. The next day, May 7th, by noon, things were going okay, but they ended up with this wind event that had not been forecasted except like immediately prior. So they didn't know about this the night before. So as they were working along the road on the south end, they started to get a lot of wind gusts, and things ended up spotting into Frijoles Canyon here, which was that real deep canyon on the Google Earth there. And once that happened, they weren't able to get a handle on it, and it spotted, as you can see on the on this east flank, up the ridge and then out of the unit to a point where it was, hundreds of acres outside of the unit. And at that point, they decided to declare it, or they decided to order a Type 1 team, and the thing was off to the races. So that was sort of, like I said, there's a lot more to it. I encourage you to read the report on this because there's a lot of interesting things that happen, of course, in between all these steps. But I just wanted to give you the flavor of how this thing evolved. And then this is where we ended up with that big run on May 7th that threatened the national lab. So you can see where the fire escaped out here on the east flank, moving towards town. It's important because when we talk about how to use these tools, I think keeping this in mind will help illustrate how we can game some things out for contingency and for holding and a few other things. So anyway, that's sort of the story of where things ended up. The rest is history. This is the yellow is the footprint of the final fire. The funny thing is it was only about, I think it was about 68,000 acres, which in our day and age is small, right? We know fires make 68,000 acre runs in a single day sometimes now. So, but back then that was a big fire. In fact, it was the biggest in New Mexico's history at the time. That was overcome again in 2011 by Las Conchas. But anyway, that's sort of the stage back in the year 2000. So what I want to do is switch now and talk about these tools and how we actually can use our tools to deal and address some of these recurring issues as it relates to this Cerro Grande fire. and certainly can translate to maybe you can think of some of the burn units that you've worked on, or maybe places where you've had issues. Maybe you didn't have to declare a escape, but now you can think back and be like, yeah, that's right. I did have problems on that one side. And maybe if I had looked at this spatially, I could have dealt with that, or at least, had the knowledge to know preemptively know that might be a problem area. So that's kind of the point of this part. So I'm going to focus mostly on element 4, which is, the description of the fire area. And then I'm going to talk a lot about the holding plan. I'm going to touch on element 7, which is the prescription, and I'll touch a little bit on the end on contingency. But these are the 4 elements I feel that IFTDS and these spatial tools can really do the best job of sort of enhancing for us as we write our plans. Okay, so IFTDS, the other thing I want to point out, like I said earlier, with Josh has done an incredible job building our help center. We've got all kinds of resources in here. So I really encourage you to go to the IFTDS homepage, all the links that are on the homepage, the webinars. We've got tons of recorded webinars, and you can scroll through those. I think the one we put in the learning portal is the RT300 I did a couple years ago, and it has those 3 parts to it. And I actually do a real demo of what I'm talking about here. So if you want to watch a demo, I encourage you to go to that webinar, and you'll be able to watch the compare weather demo. And then I do a little bit of demo on gaming out like spot fires. So if I don't have time to do that today, go to those recorded webinars. It's broken into 3 parts. They're sort of short parts, and you can kind of watch a demonstration in IFTDS, clicking buttons and stuff. But there's a whole bunch of other webinars in there too that will be informative. But we also really encourage you to use the help system. It's very extensive, got a lot of tutorials and little video snippets on how to do stuff. The learning portal also, Josh, just this week, updated the new overview of IFTDS. That's going to be released on Friday. That's tomorrow, actually. So tomorrow we'll have the brand new version of the IFTDS overview for this year. And it'll be all updated to include any of the new things that we added over the last year, since 2024. So the course that's in there right now today will actually be turned off, and the new one will be available tomorrow. So anyway, get in there and play around with some of that if you're learning this stuff. Okay, so when I think of these elements in our burn plan, I think of them sort of as a package. And I think about the organization and equipment. That seems like one of those elements that, why would you use a spatial tool to deal with that? But the reason I think about that element is because it needs to be grouped, in my opinion, with your holding and your contingency element. All of these elements really should be thought of, they shouldn't be done in a vacuum, right? All of these elements should feed into each other. And in particular, these 3. If I was going to rewrite our template that we use, I would actually put the organization element 11, I would put it at the end. And the reason I would do that is because I need to write a holding plan and a contingency plan first in order to know what my organization and equipment needs are. So I find this one to be a little out of place. So I kind of would do this in a different order. I'd go 4, 7, I'd do holding, contingency, and then I'd talk about organization and equipment. So I think of these sort of as a package deal, and they really need to be sort of thought of together. So I'll show you what I mean as I walk through these steps. Okay, so we're going to look at, this is the Cerro Grande. This is the Upper Frijoles burn plan from 2000. And, back then we, just like we do now, a lot of things haven't changed. We have our little table. This is element 4 that we call it today. We called it something different back then. And you can see we had our vegetation types, our acres, our fuel models. Remember, we were using the 13 fuel models back then. And this is the project map. So not too different from what we do today. And then this would be the breakdown of the fuel types. And this is actually a pretty good map. Remember, they didn't have land fire back in 2000. So this is actually a pretty good map. I know these words are really small in here, but the dark green is, they were calling it a fuel model 8. The lighter green is a fuel model 9. And then you can see, like we looked at on the Google Earth, the yellow and the orange were more of a grass kind of open overstory type of setting there at the top of the mountain. But they had a pretty good fuels map, actually, in my opinion, for back then. And so anyway, they were using this to decide their operation and their blacklining and things as far as their, what they put in their implementation piece. Anyway, so you can see the percentages here and the breakdown of the burn unit. Today, if we were to, do that, we have these tools now that we can get even a little more descriptive in there. But I also think the interesting thing, let me go back a slide real quick. And I see this a lot in burn plans when we do technical reviews. The screenshot of this is very tight on that burn unit. We don't see a lot of what's happening outside of the burn unit, right? It's right up to the edge of the burn unit. And here we have the ability now, right, to zoom out. And like I said, we know fires can make 50,000 acre runs in a day. Of course, that's a horribly worst case scenario that we, a lot of times we're not even burning under those conditions. But sometimes that happens, and that has happened on escape. So in my opinion, what we need to be doing in our description of our fire area is zooming out a lot more. And we have the ability to do that with Google Earth. So back to this map and looking at what is in my neighborhood. What do I care about? What are my values? And you have to decide what the appropriate distance is. But in this case, I went out about 5 miles and said, okay, what is in the neighborhood 5 miles from my burn unit boundary? And I'm primarily looking off to the east, mostly because the wind and the predominant wind direction in the time of year to burn this area is out of the west and the southwest. So I mostly care about the stuff downwind, right? So anyway, you can see that ski resort and, and all the stuff that's on the ground. The pink to the bottom is actually a wilderness area. And that's why it's a different color. So we also have Google Earth to look at vegetation. We have photographs, and I really encourage people in their element 4 to be very visual, right? You're trying to set the stage and tell your story, and putting pictures into your burn plan to illustrate these rather than just writing a long paragraph of text. Drop a picture in and write a caption. It saves everybody a lot of writing. And if I'm the reader and the technical reviewer, if I'm somebody who's coming to help you do this and implement this plan, I can read the story and get the idea way faster if I have pictures. So that's why an image like this, where you have the Google Earth 3D, you can see the terrain, and then I throw my pictures in, I immediately understand what this burn unit is all about. A paragraph of text is not going to get me there. I think about it as like if I had a children's story and I took all the pictures out of a children's story and I shoved them in an appendix. And I was trying to read this children's story to this little kid, without the pictures, or I had to flip back to the appendix in order for them to, that just doesn't work very well. So I encourage people to try to put this into the body of your text as much as you can. You don't want it to get too long, but pick the things that really help tell your story and put that in the front. So now we have land fire, right? So this was 2001, so this was a year after. And if you remember from that other image, the main burn unit from Cerro Grande actually didn't really burn. That's the kind of the ironic part of it, is when it escaped, it was because of the vegetation outside of the burn unit and some droughty conditions that we were having in the timber. That was the real issue in this escape. So being able to look out and zoom out and look at my fuel types outside of my burn unit to a much further distance, I think is really important. So now that we have land fire, we can tease out these, and then you need to check them, right? You need to say land fire mapped it as whatever. Is that right? And we have the ability in IFTDSS to go in and edit our landscape if we don't think the way land fire maps something is correct. So we can ground truth it and make those adjustments. And again, we're mostly looking at fire behavior, right? So what is the fire behavior I'm expecting outside of my burn unit, and make those adjustments to match that. This is the template now that we use today. And I think about this physical description of the area, and sometimes we overlook things like aspect and elevation. Well, you can see in this burn unit, those two things are quite important actually, because they're going to affect your fuel moistures, the time of day, maybe that you could ignite something. So the top is aspect. This comes out of IFTDSS, and elevation. And we have a very, dramatic elevation change from top to bottom. So fuels at the top versus the bottom are going to be quite different. Aspect is another really important part of our story. So I broke that down a little further, and I'll talk about how to do this funny little polygon here on the right here in just a second. But the idea is to look at inside of my burn unit. What is my aspect? In this case, on this unit, is mostly south facing, south and west. And outside of my burn unit, though, is a totally different story. It's the exact opposite. South and west is actually the least of our aspects. We've got a lot of north, northeast, northwest, and that's going to affect our fuel moistures and the way things burn, maybe the time of day that things are going to get active. So you can see in this scenario that aspect can be quite important, and it can be quite different depending on how your unit is sort of oriented. So anyway, keep that in mind when you're looking at that description of your fire area. Sometimes we kind of blow through those pieces and we just sort of check the box. But when you're writing your prescription, this can actually be really important. And we have tools to actually kind of analyze it. And same with fuel models, right? That's the same thing. Again, that's one of those recurring themes that we need to address much better than we have in the past. The fuels data inside of the burn unit, and then fuels data outside of the burn unit. And rather than writing that, we can have a table with our percentages, but wouldn't it be better just to have a bar graph? I know I can read a bar graph. Do I really care the exact percentage? Maybe, maybe not. But the point is that the predominant fuel type inside of my burn unit is a fuel model 8, at least as it was mapped by Landfire. And then I've got some fuel model 10 mixed in there. Outside of my burn unit, the predominant fuel model is a fuel model 10, which burns very differently than a fuel model 8. And this is really important because, like I said at the beginning, they characterize their fuel model as a fuel model 8 and 9, both in and outside of their burn unit. And again, it comes down to fire behavior. It might truly be a fuel model 8 in a normal year when you have normal weather and snowfall and all that. But in a year where you have drought, that thing might burn like a fuel model 10. And fire behavior, when you look at these two fuel models, just an 8 and a 10, back to our old 13, right? Fire behavior between those two fuel models is quite different. So if you have an escape in a fuel model 8, and that's what you're expecting, and it's actually going to burn more like a fuel model 10, you can see your rates of spread and your flame length are going to be drastically different. So if you're not characterizing your fuel models outside of your burn unit with the correct condition that you have at that time, it could make quite a difference in what you end up with. And that's kind of what happened in Cerro Grande. So when we're writing this element 4, I think, like I said, this is sort of an example of how you could drop some of these screenshots directly into your text, caption them, and now I've got a really nice story that helps set the stage of how I'm going to now write my prescription. So again, this is just an example of how to do this. There's no written way that you have to do it this way, but I just really recommend thinking about these things. So you're including the highlights of what's really important. Our burn plans get super long these days, and I think we can actually shorten them if we use some of these images. Okay, so that's recurring issues for element 4. I think we covered some of those, right? Description of fuels in and out, drought conditions in and out of the burn unit, using maps and photos and a lot less text. So I think if we do some of those things, we can address that recurring issue that we have seen across these 25 years. I'm just going to briefly touch on prescription. Like I said, I really want to talk about holding a little bit more. This is the prescription from the Upper Frijoles burn plan. And again, not very different from what we do today, right? A little description above, and then our table that shows our inputs, right? Our weather that we're expecting and that we want. Our fuel moistures are key to running any of these fire behavior models, whether it's behave or IFTDSS, it doesn't matter. It all uses the same inputs. And then our expected fire behavior at the bottom. And you can see they didn't include any fuel model 10 here. So your flame lengths are, in the 1 to 6 foot range, where if you had a fuel model 10, you'd actually have your flame lengths would be quite a bit higher. So when you're thinking about your prescription, you also should be thinking more about what is truly the upper end? And when you write these ranges, right, would I really burn this unit on all of the extremes? Would I burn it on the low end of my fuel moistures? Would I burn it at the high end of my temperature and my wind? Would I burn it at 90 degrees, 8 miles an hour, and these really low fuel moistures? When I do a technical review, that's one of the things I look at is, and I ask the person who wrote the plan, are you willing to burn under those extremes? And, and you might be, maybe that's what you need for your objectives. And if that's the case, that's fine, but you better have your holding and your contingency resources in play to deal with those extremes. And the other thing to keep in mind here is wind, right? This plan was written at eye level. The models that we use, whether you use Behave or in Behave, you can switch it between eye level and 20 foot. In IFTDSS, we use a 20-foot wind. So there's always that, that correction for vegetation as you're writing those. So keep wind speeds, depending on which one you're picking, is important. So a 0 to 8 eye level wind is actually a 0 to 26 mile per hour, 20-foot wind. So just a little nuance there. But we can look at that. So in IFTDSS, briefly, like I said, there's a demo of this compare weather. This is the compare weather feature in IFTDSS. And watch that little demo in the recorded webinar section. It'll show you how to do this. But basically, you run each of your ends of your prescription, right? Low, moderate, high, and then you can look at them next to each other. And it allows you to compare these side by side, and you can see the table. And what I did in here is I left everything the same. The only thing I changed was fuel moisture. That's the only thing that's different in here is fuel moisture. So on the low end, we've got higher fuel moisture, obviously. And on the high end, we've got low fuel moisture. And you can see on the map, right, the pixels on the map are going to reflect, in this case, its rate of spread. People get really wrapped around the axle about having numbers in their table. Numbers are fine, but what's really important is where that fire behavior is happening. Whether it's a 6 or an 8 or a 12-foot flame length, who cares, right? I want to know where, because can I access that? Can I get an engine in there? Am I going to need aircraft? The where is really the important part of this. So that's why the spatial tool really allows you to see the where. I also threw in a 97th percentile because that's like a fire season thing, right? I know fire season in my mind. I can visualize that. So it helps me put the rest of my prescription sort of relative to fire season. So I think these days it's hard to imagine what a low fire behavior in a prescription might look like. But when I match it up next to a 97th percentile, it's like, oh, okay, that makes a lot of sense to me now. Okay, so that's the compare weather. I encourage you to do this. You basically run each of your parameters separately, and then compare weather allows you to look at them next to each other. And you can flip back and forth to the map in IFTDSS to make changes. You can copy a run and rerun it with a different input and then compare them again. So in my burn plan, I can take the table that was just very black and white and very texty, and now I can drop in my little screenshots here, and now I can actually see that fire behavior on the map. And like I was saying, as you're talking about your holding plan next, this is all going to play into holding, right? Which it should match up with your prescription. So we can address some of those recurring issues with your prescription using these tools. Sensitivity to those inputs. In this case, I used fuel moisture. Wind might be important for where you're working. So you could tease out a little bit on the wind. And then looking at that fire behavior on the map. When we do that basic fire behavior in IFTDSS, it literally is behave on a map. It's no more complicated than that. It takes it, it runs it pixel by pixel, it adjusts it for terrain, and we use Wind Ninja in the background, so it's correcting the wind for terrain, which is a little better depiction of that fire behavior than you would get in Behave. And it shows you where, right? The numbers are useful, but the location is more important. Okay, so now there's holding. So let's run through this in a similar fashion, right? This was the holding plan and the ignition and holding map from that upper frijoles unit. And you can see, like I said, their plan was to do phase 1 and then to come down the flanks in phase 2 and then burn out the middle. And they describe that in here, and they talk about their resources that were needed for each of these phases. And it's descriptive. It's good. It talks about the roads and the hand crews and where we're going to put backpack pumps and all that, which is fine. But we can illustrate this in a better way, again, using our spatial tools and really show. And again, remember how, see, this burn unit is really zoomed in on the unit. A holding map, in my opinion, should zoom out, and you should really be looking at a lot further distance away from your burn unit edge than we have here, because holding could go quite a distance from where we're at, and access and all those other things are quite important. This unit had no roads around it. Everything had to be, it was all by foot, or they had to get an aircraft. They couldn't drive around it, which is quite important when it comes to deploying your contingency resources. So in our current day holding plan, and I know the Forest Service added both of these elements, or the one element after the national review. We've always had critical holding points and actions. And to me, that's the most important piece of a holding plan. Where are you going to have a problem, and what are you going to do about it? That's what that means. In fact, if our holding plan is all we had in it, that would be the most important piece. We did add that critical weather step-up plan, and that's that part D that got added after the national review. And the idea there was to game out those scenarios where you have a super high wind speed or a change in RH, or whatever the thing might be that might cause you problems. And we can game those things out now with these tools. And so we have a really good idea, what is our true worst case scenario? And again, this should feed right into that contingency plan. That's what I'm saying. All of these elements should sort of work together. So in this case, we can take our holding, run these different pieces of our prescription, and then say, where is my problem area going to be? So in this case, on our burn unit, this is flame length. You can see we've got some areas to the north, to the west, and then a little on the south. The east side is showing lower flame lengths. Again, that's going to depend on what fuel moistures and stuff and what fuel models that you're going to use over there. It may have been mapped by land fire and you're not satisfied with that. So you want to change it because the fire behavior outside of that burn unit is going to be higher. So you need to make those adjustments. So again, we zoomed out. So I sort of broke this into steps, right? The first thing is run that basic landscape fire behavior model, which is the behave on the map thing. Identify those values, like zoom out enough so you can see where all those values are, and make sure you're aware of where those are going to be relative to your fire behavior. And then walk through each of the parts of your prescription. So in this case, this is the low end of my prescription. And you can see my fuel moistures and my wind speeds. And then this is what it looks like when I run that for in IFTDSS. And I can just literally go in and circle the places that I might have problems. So this is rate of spread on the low end of my prescription. This is rate of spread on the high end of my prescription. And you can start to see that, as you zoom out away from your burn unit, where the issues might occur. And, does it give you like a pathway to a value that you care about? So, you might need to think about, well, how am I going to deal with that if it gets into that fuel type or whatever? So it's real easy to do this visually with these spatial tools. The other thing we don't look at a lot of is crown fire potential. You can do that in Behave, and it's very visual in IFTDSS. It's just one of the outputs you get when you run the basic fire behavior. And the reason this is important, not because we're going to have a lot of active crown fire. I mean, that's, and some obviously jack pine and stuff, you do have that, but it's where torching is going to happen, right? And torching is what causes us problems. So here you can see this burn unit is surrounded by places where torching is going to be an issue. So you need to keep that in mind just in general. And this is on the low end of my prescription. So again, I can take these, I can drop them into my plan. I can write what my critical holding points and actions are, but I can show them, which is even more informative than just talking about it. So I drop these in here, and now think about it. If I'm a boss and I'm helping with this burn unit and maybe I'm not super familiar with it, this immediately helps me say, okay, these are the places we're going to have to focus on. And then I can talk about my contingency resources. So again, addressing those recurring issues, running those models, looking outside in your burn unit, but also outside of your burn unit, circling or identifying the areas where you're going to have problems. And then again, like that element 11, like I said, now I can start talking about my organization and what equipment I'm going to need to deal with holding. And the same thing goes with contingency. So I know I'm getting to the end of my time here. So I want to kind of just finish up this last little piece. I'll kind of go through this quickly. Again, their contingency plan had, a lot of text, which is fine. It's okay. You need to write this stuff down, of course. But if you threw in a few images, in this case, in IFTDSS, we can game out some spot fires. It's a little more advanced model. It's the minimum travel time model is what we call it. If you're not super comfortable with this, I recommend talking to somebody who's a fire behavior person to help you run these and kind of analyze them. But you could put some spot fires in a place you know is going to be a problem, and then see under certain weather conditions, how far might the fire go? And then you can use this little tool we have in IFTDSS, which is the measuring tool. And if I run I know this might be hard to see on your screen, but you can run that model and then take the little measuring tool and figure out how big is that spot fire going to be. In this case, after a 1 hour burn period with a 13-mile-an-hour wind out of the south, it comes out to be about 70 acres. So we use contain and behave, right? But now we can sort of visualize things a little bit more on the map and say, whoa, 70 acres, that's going to be tough to catch. What am I going to need? Or maybe I just need to burn under a little different prescription. Or maybe I have to break this thing into different phases like they did and burn it under different weather. Each phase might have to have a different prescription just so your holding will be appropriate. So that's kind of how you can work with contingency and some of the tools in IFTDSS. I was curious about that ski resort to the north, so I ran one to see how far it would go. And you can see after 2 hours, this was with a wind event, like a worst case scenario, 30 miles an hour. Wow, it could really go. I mean, it's really going to go off to the races to the north. So again, cautioning you against some of those worst case scenarios. But we can look at it in Google Earth, and I'm super informed now about, oh boy, how am I going to deal with that? And then we have other tools too, like from the RMA dashboard, using those potential control locations. Those are available in IFTDSS. We pull them right from the RMA dashboard. And this is not a bad thing to use for your contingency either. You can really look at where is my best effort for control if I do have an escape. And you can see in this particular, you can see the green, right? That's where the easiest place to control this fire is going to be, which is exactly what happened in the whole scenario, right? It burned across this landscape and towards Los Alamos, and they couldn't catch it until they got to these roads. So that's another way to use it. Same thing with the SDI, the suppression difficulty index, very similar to PCL, just a little different spin. How hard is it to put the fire out and where, based on terrain and vegetation and things like that. So use those layers too that are in there. They can help inform your plan. So that other recurring issue with contingency, this should help inform your organization. And I think we can check the box on some of those recurring issues if we use sort of this series of tools. So from 2000 to 2022, again, we've had all of these different events, and we've had lots of events in between. Some are notable, some are not. But learning from these things and seeing where these problems happen, I think it's an incumbent, we have to do this. Like we're being negligent, in my opinion, if we don't. If we're not learning from these things and changing our behavior, then there's no reason to do any of the, the lessons learned stuff that we do. So let's think about this. Look at these reports. I learn a ton learning from reading these reports. And let's try to reduce. I'd rather be talking about I don't want to talk about recurring issues anymore. I want the ones that we've always had. I'd rather talk about a new recurring issue, like the drone crashing and causing a spot fire. That would be new in 21st century. Some of these other things, I think we need to be reducing these a lot. Let's put those to bed and move on with, there'll be new things that come up, but we can reduce what we've had in the past for sure. And I go back to Paul Gleason, of course, and again, he was on that Cerro Grande fire, and we really should be students of fire, right? That's the real way to do the best we can with the work that we do. And I respect every single one of you for doing this stuff. It's not easy. And it's risky, and we're really hanging ourselves out there sometimes, but it's the right thing to do. So why should we use these tools that we have now? Because we can, right? We didn't have them back then, but we have them now. And I think it's imperative that we use them. So that's what I got. So I really appreciate you guys letting me come and chat with you all today. I know that was a bit long, and I went through it quite fast. So, but thanks.
Actually, Kim, I want to say a big thank you to you, not only you, but also your team for your work in developing this, and also with your presentation. When I started out as a burn boss, the highest technology that I used during that time was using, I think it was Behave DOS. I forget what version it was. I was also making maps using photocopy topographic maps, and then using colored pencils. That was back in the day. What you all have developed and what you all have provided, I can't think of any other tool or any other invention to date that will allow us to create and develop burn plans to meet the quality that we require now. I mean, it's such powerful information. And I know we do have quite a few folks that use IFTDSS, but we also have quite a few folks that don't use IFTDSS. And hopefully, this will be the beginning journey of our crusade to improve our burn plans across the agency, but also it's specifically for Region 9.